So, hello everyone. Today we are going to discuss the group 16 questions. Group 16 of P block elements. Previous year questions. Board questions. Okay. So first one. First one is, how will you account for the following? Question is electron gain enthalpy. Question number 1. Electron gain enthalpy with negative sign. For oxygen, that is minus 141 kilojoule per mole is less than that of sulfur. Yes, it is minus 200 kilojoule per mole. It is given to us. Okay, this is the question. So account for the following. Why electron gain enthalpy with negative sign for oxygen is less than that of sulfur? Or it is asked in other way, that value of electron gain enthalpy with negative sign for sulfur is higher than that of oxygen, or electron gain enthalpy with negative sign is less for oxygen than for sulfur. So tell me, what is the reason? Last thing. Okay. So tell me, what is the reason for that? So it is because of very simple reason is there. Like same is applicable for fluorine and chlorine, oxygen and sulfur. Same reason, that electron gain enthalpy with negative sign for fluorine is less than that of chlorine. What is the reason? Reason is the size. Reason is the size of oxygen atom is smaller than that of sulfur. This is the reason actually, because when electron is added to neutral gaseous atom, the electron repulsion experienced in the smaller 2p subshell of oxygen are comparatively larger than those of the bigger 3p subshell of sulfur. That's why more energy is released. See, oxygen gas, when electron is added in this case, then O negative gas is formed. Electron gain enthalpy is only minus 141 kilojoule per mole, which is already given to you. Okay, and for sulfur, the electron is added, electron gain enthalpy is minus 200 kilojoule per mole. The reason is simple, the small size of oxygen. Small size of oxygen, and due to this small size, when this electron enter into it, the electron repulsion is more. Okay, because electron repulsion is more in small 2p subshell. In oxygen there is 2p subshell, small 2p subshell. Okay, but in sulfur there is large 3p subshell. So electron repulsion experienced is less. in case of 3p. But in 2p subshell, electron repulsion is more. So this is the proper reason for this question. And this question came in 2009, 2008, 9, 10. CBSE 2009, 8, 9, 10. Maybe asked now. Yes, this year. Okay. Next is sulfur has greater tendency for catenation than oxygen. Sulfur has greater tendency for catenation than oxygen. Yes, tell me, what is the reason? Hello everyone. Tell me, sulfur has greater tendency for catenation than that of oxygen. What is the reason? Again, reason is small size of oxygen. Again, the reason is due to smaller size of oxygen than sulfur atom. So because of the small size, lone pair repulsion is more from the lone pair bond pair repulsion. In case of oxygen, it is more, okay, than that of sulfur, because in sulfur, due to large size, lone pair density is less. Very good, beta. From Grewal, Ashish, good. And therefore, you can simply write due to small size of oxygen and due to inter-electron repulsion, due to because lone pair repel more. Lone pair repel this OO bond more than in case of sulfur. So sulfur bond, single bond, is stronger than that of oxygen bond. Sulfur single bond is stronger than that of oxygen bond. That's why sulfur has much greater tendency for catenation, because catenation, as I said earlier, catenation is directly proportional to element single bond strength. Element single bond strength. Next question. Question number 3. Tell me why H2S is acidic while H2O is neutral. Why H2S is acidic while H2O is neutral, or we can say H2S is stronger acid than water. Or more acidic than water. Yes. The reason is again same. Because of large size of sulfur, hydrogen sulfur bond is weaker. Hydrogen sulfur bond is weaker than OH bond. Hydrogen sulfur bond is weaker than OH bond because of size of sulfur atom. okay, which is bigger than that of oxygen. So H2S can dissociate to give H plus ion more easily than H2O, obviously. Okay, H2S can give H plus ion more easily than H2O, and dissociation constant of H2O is so small that for all practical purpose H2O is considered to be neutral. Dissociation constant of H2O is so small that for means most of the practical purposes H2O is considered to be neutral. Okay, this is the reason. Yes, size is the reason. Even next question, H2S is less acidic than H2T. Same reason, due to large size of tellurium than sulfur, HS bond is stronger, or we can say HTE bond is weaker than HS bond. Okay. Question number 5. SF6 is known. SF6 is known, but SH6 is not known. Now explain. Yes, what is the reason? Yes, now reason is different. SF6, you know, it is well known, but SH6 you never heard. Okay, because it does not exist. So why? So now reason is, you know, fluorine. Fluorine is, fluorine is the strongest oxidizing agent that you know from its reduction potential. Fluorine being the strongest oxidizing agent oxidizes sulfur to its maximum oxidation state of +6. Okay, that's why sulfur can thus form SF6. But if you talk about H2, H2 being weakest oxidizing agent, rather it is a reducing agent, so cannot oxidize sulfur, right? That's why cannot oxidize sulfur to maximum oxidation state of +6. That's why does not form SH6, right? This is the reason. Next question. Why the compound of fluorine and oxygen are called fluorides? Compounds of fluorine and oxygen, they are called fluorides of oxygen, and not the oxides of fluorine. Why? Like OF2, it is oxygen fluoride, but not fluorine oxide. Yes, beta. What is the reason? It is very simple question. Because fluorine form anion here. Okay. Because fluorine is more electronegative than oxygen. This is the reason. Because fluorine is -1 and here oxygen is +2. Okay. Next question. SCl6 is not known, but SF6 is known. Okay. Harsh and Harshil, good evening. Yes, tell me. SCl6 is not known, but SF6 is known. What is the reason? Yes. So reason is, you know, fluorine again being a stronger oxidizing agent can oxidize sulfur to maximum oxidation state of +6. Therefore, SPF6 is not known, but chlorine, because of two reasons. First reason is sulfur being weak oxidizing agent cannot oxidize sulfur to maximum oxidation state, and second reason is due to its large size of chlorine. Because of larger size of chlorine, what happened? Large sized 6 Cl atoms cannot be accommodated around sulfur, okay, due to steric hindrance. So this is the proper reason. Okay. Now question number 8. This is important. Sulfur hexachloride is used as a gaseous insulator, electrical insulator. What is the reason? Why it is used as an electrical insulator? Yes, beta. What is the reason? First of all, SF6 is, yes, SF6 is thermally stable and chemically inert. Or even we can write it is colorless, odorless, non-toxic gas. Right? So because of its inertness, first thing, because of its inertness and high tendency to suppress the internal charges, internal discharge, okay? So it is used as a gaseous electrical insulator in generators, in high voltage generators, okay? And switch gears even. So because of its, you can write, first of all, there it is a colorless, odorless and non-toxic gas. First reason. Second is it is thermally stable and chemically inert. So because of its inertness as well as its tendency to suppress the electrical discharge or internal discharge, we can say. High tendency to suppress समझते ना, कम करना. Okay, that's why high tendency to suppress internal discharge. It is used as a gaseous electrical insulator. Okay. And this is question number, this was question number 8. Okay. Question number 9. SF6 is kinetically an inert substance. Yes, tell me why it is electrically, sorry, it is an inert substance, kinetically inert substance, or it is inert towards hydrolysis. Or SF6 is much less reactive than SF4. Yes, tell me what is the reason. Now it should be two-way. Okay, add something. Yes, beta. So sulfur fluorine. Yes, it is protected by 6 fluorine atoms. Because of these fluorine atoms, it is sterically protected. Okay, sulfur is sterically protected by 6 fluorine atoms. Okay, and that's why it does not allow water molecules to approach. Okay, it does not allow, see, water molecules cannot approach sulfur, first thing. Okay, and second thing, fluorine does not have vacant d orbital. That's why it does not accept the electron pair from the water. Is to accept the electrons donated by H2. Okay, and this is because of these two reasons. SF6 is inert towards hydrolysis and it is kinetically an inert substance. Got it? Very good, Harshil. Don't worry if you don't know, I'll let you know everything. Okay, so reason is sulfur is sterically protected by 6 fluorine atoms. That's why water cannot approach it. Okay, water cannot enter into it. Okay, means it does not allow water molecules to attack sulfur atom. First thing. Second thing, fluorine does not have vacant d orbital to accept electrons that is donated by the water molecules, and that's why SF6 does not undergo any hydrolysis. But if you say some other SF4 that is not statically protected, and that's why that can be easily attacked. Done. Next question. Sulfur exhibits greater tendency for catenation than selenium. Sulfur that exhibits greater tendency for catenation than selenium. Yes, tell me. Again, same reason. You know, sulfur being small, sulfur-sulfur bond is strength of sulfur-sulfur bond is stronger than selenium-selenium bond. Sulfur-sulfur bond, because of small size, is much stronger than selenium-selenium bond, and that's why sulfur can show catenation. Okay. Next. All bonds in SF4 are not equivalent. Tell me the reason. All bonds in SF4 are not equivalent. Can you tell me? Very good, beta. Because you know in SF4, you know sulfur has what is the hybridization of sulfur? You can write hybridization, okay, of sulfur is, you know, 4 bond pairs and 1 lone pair. So it is 5 sp3d hybridization. Sulfur is sp3d. So sulfur, it has 1 lone pair and 4 bond pairs. It has seesaw shape. So equitonal bonds are smaller than axial bonds, being more repellent. That's why all the bonds are not equivalent. Okay, equitonal bonds are smaller and axial bonds are longer. Next question. Question is sulfur disappears when boiled with an aqueous solution of sodium sulfite. Yes, what is the reason? Good, Harshil, Saad, very good. What about others? Please do participate, beta. Yes, this is the very important question. Sulfur disappears when boiled with an aqueous solution of sodium thiosulfate. Yes, what is the reason? What happened actually when sulfur is with sodium sulfide? Sulfur react with sodium sulfide. You know, sulfur react with sodium sulfide to form sodium thiosulfate. No, H2S is not formed here. Sodium sulfide. Sulfur reacts with sodium sulfide to form sodium thiosulfate. Form sodium thiosulfate, and hence sulfur disappears. Okay. Yes, draw the structures of PCl5 and SO3 2 negative. PCl5 and SO3 2 negative. So in gaseous state, it is a trigonal bipyramidal shape. Shape is trigonal bipyramidal. But in solid PCl5, solid PCl5, it exists as, yes, we have discussed it. Solid PCl5 exists as PCl4 positive and PCl6 negative beta, in which PCl4 is tetrahedral. We have already discussed it. And PCl6 is octahedral. Okay. Tetrahedral, and this one is octahedral. Yes, what is the shape of SO3 2 negative? Means out of 10, 7 are confused with the shape of SO3 2 negative. Tell me the shape of SO3 2 negative. Yes, beta. What is the shape of SO3 2 negative? Fast. Shape of SO3 2 negative. Trigonal pyramidal. Very good, beta. Very good. Actually, in SO3 2 negative, there is one lone pair. Okay. And 3 bond pairs. So it should be like this. Okay. Shape is pyramidal, or we can say trigonal pyramidal. okay, due to the presence of lone pair of electrons, right? Now, question number 14. Last question of the day. Just a quantitative method. It is important one. Just a quantitative method for the estimation of a gas which protects us from UV rays of the sun. Yes, beta. Which gas is this? Everyone knows. I think even means primary class student knows it now. Yes, beta, jaldi. So, beta, you know all ozone. It absorbs UV radiation and thus it protects us from the harmful radiations of sun. So, to estimate this, what we do, actually, ozone is an oxidizing agent. So, ozone oxidizes potassium iodide, okay, to I2, and along with the formation of O2 and KOH, right? After the formation of I2, this I2 thus liberated, that is titrated against standard solution of sodium thiosulfate using starch as an indicator, and we get sodium tetrathionate along with sodium iodide, okay. Done. So in this way, amount of O3 can be estimated. So to estimate ozone quantitatively, what we do? See, ozone, it is titrated with potassium iodide solution, and ozone oxidizes potassium iodide into I2. Okay, and this I2 liberated during this reaction, it is titrated against standard solution of sodium thiosulfate, okay, using starch as indicator, and therefore in this way amount of ozone can be estimated, okay. Now tell me, nitrogen oxide which is emitted, nitrogen oxide means nitric oxide, which is emitted from the exhaust system of supersonic jet aeroplanes, slowly deplete the concentration of ozone layer in the upper atmosphere. Yes, tell me how. Nitric oxide present in the or emitted from the exhaust system of supersonic jet aeroplanes. It slowly depletes the ozone layer. Okay, concentration of ozone layer in the upper atmosphere or stratosphere. Okay, so comment on this. NO present in this, it combines readily with ozone and it forming O2 and NO2 gas. Okay, and therefore it depleting the concentration of ozone in the upper atmosphere. This is the reaction. Okay, so this is all about the questions of group 16. That's all for the day. Thank you so much for watching. Bye beta.